Here he goes. Woohoo! Yeah!
Welcome!
Okay, you are watching the right video actually, but thought I would start with that. Hey guys, we are today going to be adding, subtracting, multiplying polynomials, and I'm going to do a quick segment, and then we're going to go watch some more of that video, and then I'll finish up the video in a second. But let's do the first page first, and then we'll take a break. And I think what you're going to find is that this is actually pretty easy because we've done all of this before. Now, the last week and a half, we've really been doing monomials, which meant one term. Polynomials, surprise, means multiple terms. Okay, multiple terms. There are some directions, and it says add or subtract, and we're going to put and also multiply, because that's in there too. The first thing you're going to do is LCO. That's going to be the most helpful thing for you. That way you can see if you're distributing a -1 or if this number is actually positive or negative. And some of us used KFC last year. Whatever three-letter acronym you use to turn addition to subtraction, subtraction to addition, that's what you want to do first. After you've LCO'd, then distribute. Again, I can't spell. Distribute. That's what we want to do next. And lastly, combine like terms. So those are the three main steps. And again, you've done this before. This is nothing new, more or less. So we're going to jump right into some examples. I'm going to do one, and then I'm going to have you pause it and you try one. And then same, we'll repeat that process just to make sure that you're understanding what's happening. So if we look at this first one, 3x squared, blah, 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 blah. That's a big polynomial, lots of terms. There's nothing to distribute, but I do want to LCO this so that it's 3x squared plus -4x plus 8. And then there's a lot of LCOing that needs to happen in the second polynomial. So plus 2x plus -7x squared. Sorry if you're running out of room, I am too. I'm going to erase this before I do the next example. Plus -5. So, again, we've LCO'd. Now the second step was distribute. There's nothing to distribute. So the third step, I just need to combine like terms. And we talked last week about if they don't have the same exponent, it's not the same term. So I see two things that are squared. Those are the same term. So I'm going to combine their numbers. 3 plus -7 is -4. And I'm going to keep the term the same. I'm not going to change the exponent. You only change the exponent if it's being multiplied, divided, or raised to a power. Here we're just adding the two numbers together. So we're going to leave it as -4x squared. The next term I see is one where the exponent is 1. So I have -4 and +2 for a total of -2x. And lastly, I've got just these singular numbers, 8 and -5 for a total of +3. I cannot simplify this any more than -4x squared plus -2x plus 3. That's as far as I can go. At this point, I'm going to have you pause the video and try this next one on your own while I erase this madness. So the first thing I did was I LCO'd that to plus -4. And now I can combine 6n squared and -2n for a total of 4n squared. The next thing I can combine are these singular numbers, -4, +9 for a total of +5, not 9, yikes. So that's it. I can't combine anything else. That's as far as I can go. We're done. Hopefully you got that. We're going to keep moving on. These next two are really nothing new, other than one thing, and the emphasis really focuses on this LCOing rule. So as I look at this first one, there's nothing to LCO here, but there is a subtraction sign here. So as I leave this first term, change to plus, I've got to make something negative. It's -1. So outside of these parentheses, I have -1 times the inside, 4n cubed. So when you LCO something that's between two sets of parentheses, essentially you're making a distributive property for that -1. So that when I distribute -1 in, it becomes -7n and -4n cubed. So now I'm ready to start combining things. And if I look at my exponents, I have 13 and -4 share the same exponent, so I can combine them for a total of 9n cubed. And then there's only one thing that's squared, so that's just going to stay plus 3n squared. And then I have 5n and -7n for a total of -2n. And that is all that I have. I have no other numbers or variables to combine, and that's as simple as it can go. At this point, I'm going to have you pause the video and try the next one on your own. Okay, so as I distribute this -1 into this, it's going to become -3. And this is -6d squared, so -1 times -6d squared is positive 6d squared. So now I'm ready to combine things. I can combine 4d squared and 6d squared for a total of 10d squared. And I can combine 11 and -3 for a total of positive 8. As we talked about last week, the order that these need to go in is in descending order in terms of exponents. So the highest exponent always needs to come first, followed by the next lowest, followed by your single number needs to come last. So a number without a variable. Right, moving right along, I've got more space to write here. Pretty much the same rules. LCO first, so I can LCO this to be -7. And then you're going to distribute next. That is -6x. And remember, when I multiply exponents, you're really adding. So 2x's and 2x's for a total of 4x's. Then I have plus -2x squared times -7x is positive 14. And then I've got 2x's here and 1x there for a total of 3x's. And then as I distribute to this last part here, it's going to be -20, and x squared will just be its new variable. Lastly, check C, can I combine any like terms? In this case, nope, so I am finished. Go ahead and pause the video and try this next one on your own. Alright, hopefully the first thing you did was LCO'd it. That's what I did, and now I'm ready to distribute. 5 times -3 is -15. And then when I add those exponents, I'm going to have x to the 6th power. Next, I'm going to have 5 times 2 for 10, and x will be raised to the 5th power. Next, I'm going to have 5 times -5 for -25, and x will be to the 4th power. Notice my exponents are in descending order so far, so that's good. 5x squared times -x is -5x. There's a -1 in front of this x. So that's going to make that -5, and it's x cubed. And my last one, 5x squared times 2 for a total of 10x squared. All of these have different exponents, so there is nothing I can combine. I am finished there. And since we are finished with the first page, I'm going to bring you some more epic water fails.
Ready.
All right, and back to some math. We're going to hit page 2. And again, I'm just going to pause this after I do the... All right, so we're ready for the next page. So, again, we're going to LCO first. And there's only 2 things we need to LCO, so here and here. So now I'm ready to distribute. Y times y, that is a total of y squared. Y times -12 is -12y. Plus, more distributing, y squared. And that is 2y. and I'm left with just 25 on this side. On the other side, it's a lot of the same thing, so some distribution over here. 2y times y, there are 2 y's there, so y squared, plus 2y times 5 for a total of 10y plus negative 15. Before I start moving stuff from one side of the equal sign over, there's some stuff I can combine. Y squared and y squared is going to be a total of 2y squared. Negative 12y and negative 2y combined for a total of negative 10y. And 25 isn't going to combine with anything over here. On this side, there's nothing I can combine, so I'm just going to kind of leave that alone. And at this point, I'm ready to start moving stuff over across the equal sign, because since these two equations are equal, I'm actually going to be able to figure out the value of y. That's what I want to know. I want to see, what does y equal? So I can combine this 2y squared with this 2y squared because those have the same variable. And nicely enough, these are going to cancel out on both sides. I can also combine these right here, these negative 10y on each side. So these are going to cancel. Negative 10 and negative 10 equal negative 20y. And I can lastly combine the single digit numbers. So if I subtract 25 on each side, I have that negative 20y equals, this is a total of negative 40. From here, I should be able to divide both sides by negative 20. And I find that y equals positive 2. So following all the same rules, I figured out what the value of y is. At this point, I'm going to have you pause the video and try this next one on your own. So welcome back in. As you can see, I've already done this on my screen for the sake of time. If you did not get negative 5, maybe just pause this video and kind of see how my work compares to yours. My guess is that you probably messed up somewhere over here. So maybe redistribute that again. Just remember that 1n times 1n equals 1n squared. 1 times 1 is 1, n and n is 2 n's. On to the last section. This is going to be a little bit different, but let's go and do it together. That's y cubed. I didn't follow my rule of LCOing first, did I? No, I didn't. There it is. And this becomes 12y plus negative 8y equals, on the other side, 14 plus, this also becomes y cubed, plus negative 4y squared. Before I move stuff from one side of the equal sign to the other, I can combine those. That becomes 4y. And over here, there's nothing I can combine. So let's start moving stuff over. I'm going to start with this y cubed. We have not messed with that yet. But luckily enough, as I move it from one side to the other, it's going to cancel out on both. So that's gone. And then I'm left with a bunch of random terms, 4y and 14 and negative 4y squared. The next unit coming up, once we have something like this, we're going to figure out how to figure out what y is, because right now I can't. For now, what I'm going to say is move everything to the same side of the equal sign. So to make this easy, let's just move this over here. This is going to cancel, so I have 0 on this side. And remember, we need it in order of exponents. So my negative 4y squared will come first. That has the greatest power. Followed by the one with just one exponent. Followed by my single number. And for now, we're done, because we don't know how to figure out what y is yet. But in the coming weeks, you will. The last thing that I have for you here, I'm going to do it on Schoology just for the sake of time. But this is pretty easy. So check out the example on Schoology. It's a screenshot. And other than that, I hope you guys had a great day. And I will see you guys when I'm back on Wednesday.